Good morning, everyone, and welcome to Linear Relations. Today we'll be dealing with grids and problems around ramps, slides, and slopes. By the end of today's lesson, the goal is that you will be able to make your own coordinate grid and plot a set of points, as well as calculate slope, using either one of the two methods we'll be discussing later in the lesson. So let's get started. First things first, there are some important vocabulary for us to remember. Graphs, and linear relations in particular, usually compares two things. We have the independent variable, which is the one that affects another variable, and the dependent variable, which is the one that is affected or the one that depends on the other variable. Think of it as watering a plant. How much the plant grows is dependent on the amount of water we use. In this case, if we don't water the plant won't grow and it will die. This means that the independent variable is the water, because it's the one that controls how much the plant will grow. Whereas the plant growth is the dependent variable since it depends on the water. Another important term to remember is a Cartesian plane, which refers to this grid that we have on the bottom. A Cartesian plane, or a coordinate grid, is a two-dimensional four-quadrant grid. The bold lines are the x and y axis. The horizontal axis, or the one that goes from left to right, is known as the x-axis, and that represents the independent variable. The vertical axis, or the one that goes from top to bottom, is the y-axis, and this represents the dependent variable. Okay, so looking at our grid, it also says to label the quadrants as follows. So it says quadrant 1 is on the top right, so I'm just going to put in Roman numerals 1. Quadrant 2 is going to be on our top left. Quadrant 3 is going to be the bottom left. And finally, quadrant 4 is going to be on our bottom right. Any point on our Cartesian plane can also be represented as an ordered pair in the form of x, comma, y. So it's important here to remember that x comes first in our coordinate. The x and y axis also meet at the point 0, 0, known as the origin. They meet and intersect right over here at 0, 0. Okay, so let's try example 1. So again, if you weren't able to print the worksheet, please feel free to pause the video and draw yourself a Cartesian plane similar to this one. The first thing we could do is create our x and y axis. So we have our grid here on the worksheet, and what we're going to do is draw the up-down axis, and we're going to label this y, and then we're going to make our x-axis and label it x. The next thing you want to do is to label it, so think of it as a number line. So for the x-axis, I'm going to put here -6, -4, -2, and then the point that they meet, that's going to be 0, 2, 4, and 6. Same goes on the y-axis. We go -6, -4, -2, 0, 2, 4, and 6. Great job. The question says, draw a Cartesian plane, which we have, and then plot and label the following points on the grid provided. Well, before we plot any points, why don't we first label which coordinate is the x and which coordinate is the y. So if you remember, the first number is always the x value, and the second number is always the y value. So under each point, I'm just going to write x, y, and so on for each of the points. That way we could easily differentiate between which point is x and which point is y. All right, good job. So the first point, A, is 2, 4. So the first thing we're going to look for is 2 on the x-axis. So if we go down on the horizontal axis, we see that 2 is right over here. The y-coordinate is +4. So that means when we go on the y-axis, we'd be looking over here. If we line those up, you'll find that they both meet here at this point. So here we'll plot our point, and we're going to label that with the letter A. Great job. For B, The x coordinate is -3. So this time we're going to be on the left side, and we find -3, and our y value is 5. So this time we're going to go up again and see that 5 is over here, and that the 2 will meet up at this point. Using the same method, we're going to plot our point and then label that point B. Okay, why don't we do one more together? So for C, the next point is 3, -4. Following the same method, we're going to go down on the x-axis and find 3, and then we're going to go on the y and find -4. And if you see for this one, they meet at this point right over here. So here I'll ask everyone to pause the video and try plotting point D on your own. So hopefully you were able to find that for D, you should have your point here. Now for points E and F, we'll follow the exact same method, but the only thing is, now we have these decimals. In E, we have 2.5. In F, we have a fraction like -7/2. For E, 2.5, that's just going to mean that we're in between 2 and 3. So if you go on the x-axis, that would be just about right over here. And on the y, we're at 2. So I'm going to plot this point right here. For F, we have a fraction of -7/2. So what I want you to do is actually you could plug this into your calculator. And what we're going to do is convert this to a decimal. Once I plugged it in, I find that that's actually equal to -3.5. This means that similar to point E, this is in between -3 and -4. Now first, it's important that we first do the x, so we're going to go on x and find +4. And then on y, we find -3.5, which is right in between here. Match those up, and then we plot our point. Okay, example 2. The question says, state the coordinates of each of the aliens plotted on this Cartesian plane. Which quadrant is each alien in? Unlike the first example, in this question, we are given the points, and what we have to find are the coordinates. So let's take the purple one, and let's do this one together. If you look at the grid, the purple alien would be this one. Well, we know our coordinates are always in x, y. So first, let's find the x value that corresponds to this purple alien. As we go down the line, we see that he's on number 2. And if we look at the y-axis, we see that he's on +6. This means that we could write the coordinate as 2, 6. Perfect. Okay. Well, what quadrant is he in? In order to do this part, why don't we label each of the quadrants as 1, and again, top left as quadrant 2. This one is 3, and the last one is 4. That means that since this alien follows in this quadrant, we could write that he is in quadrant 1. Okay, let's try the next one. The green alien is located right over here. Using the same approach, we look for x and find that this is going to be on +4. And in terms of y, it lines up to here, which would be -5. Therefore, the coordinate for this alien is 4, -5. Since the alien is in the bottom right, we could say that it's in quadrant 4. We'll do one more together. And this time, I'm going to pick the yellow one because he kind of looks like Mike Wazowski from Monsters, Inc. Hopefully you guys are familiar with that movie. And this one could be a little tricky. So, our yellow alien, or our Mike Wazowski imposter, is right over here. What do you think the x-coordinate for the yellow alien is? Well, if we follow along the x-axis, we see that it is right in the middle, and it's actually located exactly on the axis. This means that it has an x-coordinate of 0. You might be thinking, well, it's on the y-axis. Why is the x-coordinate 0? Well, remember that x goes from left to right. So if we were to think of this as a number line, so I'll quickly draw a number line, we see that the yellow alien falls right in the middle at 0. On the y-axis, using the same concept of the number line, we remember that this goes from bottom to top, or top to bottom. We see that it falls on -3. Therefore, the coordinates for our Mike Wazowski imposter, or the yellow alien, is going to be 0, -3. Now, because it falls right in the middle, we could say that this one is actually in between quadrant 3 and quadrant 4. Great job. Okay, so now I want you to pause the video and try labeling the other 3 aliens on your own. Let's do example 3. So it says, in the chart below, list 3 points in each quadrant and describe what they appear to have in common. So the first point we have, or the first quadrant we're going to do, is quadrant 1 here. So if we go back again, if we just quickly scroll, if you label, if you remember, this is going to be quadrant 1. This is going to be quadrant 2, quadrant 3, and quadrant 4. So what I'll do is I'll pick any 3 points here in quadrant 1. So for example, we could pick 2, 2. We could pick this one, which would be 5, 2, and we could pick, for example, this one, which would be 6, 5. So if I go back to my table and we list those 3 points, we said they were 2, 2, 4, 2, and 5, 6. There's an infinite amount of points really you could put in quadrant 1. The idea here is, if you notice, that they're all positive. So where it says what do they have in common, we're going to say that both x and y are positive. When we're dealing with quadrant 2, so let me make a grid just so we don't have to keep referring back to it. Quadrant 1, 2, 3, and 4. Quadrant 2 is going to be right over here. And if you remember, this is going to be our x-axis. This is going to be our y-axis. And if you wanted to find 3 points in quadrant 2, that could be, for example, this one. We'll just make up as -3 and 4. We'll say -2 and 2. And maybe another one at -2 and 6. So using those 3 points, we'll write them over here. -3, 4. -2 and 2, -2 and 6. Well, what do you notice? In this case, all the x coordinates are negative. So what we're going to write here is we're going to write x coordinates are negative. But because it's in the up, or the upper half of our grid, the y is still positive. So we're going to put y coordinates are positive. Okay, perfect. So just to minimize confusion, we'll get rid of these points. Now we're working with quadrant 3. So in quadrant 3, what we have now is we're working with this quadrant. So think of it as, again, let's say this is -4, and we'll say this is -3 this time. We'll just make up some numbers. We'll say -3 and -2, -4 and -5, and maybe -4 and -7. So we'll quickly write those points down. And again, I just made any of these coordinates up. Any points that fall within this quadrant is essentially what you're trying to find. So if you have different points written compared to mine, that's perfectly okay, as long as you come up with the same things when you're answering what do they have in common. So in this case, you find that the x coordinates and the y coordinates are both negative. So we're going to write both x and y are negative this time. Okay. Last one is quadrant 4. So I'm going to erase this. What we're going to do is maybe we could keep this. Quadrant 4, we're working with the bottom right here. And that's going to be dealing with x values on the positive end. So let's say this is 3, 4, and 5. And the first point we'll say is over here, and over here. That means we have 3, comma 7. Sorry, negative 7. 4, let me just fix that. 4, comma negative 2. And 5, comma negative 5. If you look here, this time all the x coordinates are positive. And that's again because we're on the positive side of the x number line, or the x-axis. And in this case, all the y values are actually negative because we're on the bottom half of our grid. So here we're going to write x coordinates are positive, and that we're going to write that the y coordinates are negative. Okay, moving on to slope. Slope is a measure of a steepness of a line. So if we have any skateboarders in the class, whenever I mention slope, think of when you went down a ramp. Whereas the steeper the ramp, the scarier it might be, and the faster you'll go down the ramp. If you're like me and have never skateboarded before, think back to your childhood when we used to go down slides. So what does that look like in a linear relation? Well, now that we're expert at plotting points, what if we had 2 points like this one, point 1 and point 2? To make a line, all we need to do is to connect the points. And if we wanted to make the line go further, simply take a ruler and extend that line in both directions. Now again, slope measures steepness. So the steeper the line, the bigger the slope. Our objective in this part of the lesson is to find slope, or rather, just how steep that line, ramp, or slide actually is. So how do we calculate slope? Well, slope is represented by the variable m. And in our equation, we could see that m is equal to rise over run. Now you might be thinking, what is rise and what is run? Well, rise represents the vertical distance, keyword vertical, between 2 points, whereas run represents the horizontal distance between the same 2 points. It's also important to note that slope is a ratio. So when we're calculating slope, it shouldn't have any units. So what does this look like in the context of ramps and slides? Well, if we go down to our example, and we see here, we see that it's labeled run over here on the horizontal, again, of the ramp, as well as the slide. And then rise, think of that as your height of the slide or the height of the ramp, because that determines how high you go or how much you go in the y direction. So let's try example 1. Find the slope of a wheelchair ramp that has a run of 20 meters and a rise of 2 meters. Well, the first thing we could do is to write down the equation. So if you remember, m is equal to rise over run. And I'm just going to write here, again, when they ask for slope, what they're looking for is m. Another thing we could do is to draw out a ramp. Now, it doesn't have to be 3D, kind of like in the example shown above. It could just be a simple right angle triangle. that we're actually going to label. So if you remember the horizontal distance, that'll be our run. And in this case, it's 20 meters. And the vertical distance, that's going to be our rise. So in this case, it's going to be 2 meters. Okay, so if we plug that back into our equation, we get that m is equal to 2 over 20. Now, it's important to note here that we do have a fraction. And because we have whole numbers, we're actually going to leave it as a fraction. So we could simplify this to 1 over 10, but you wouldn't want to change it to 0.1111. Is basically what you would get if you were to type that in a calculator. We'll leave it as 1 over 10. So what does this mean? Well, this tells us that for every 1 meter, so I'm going to say the ramp rises 1 meter vertically for every 10-meter run horizontally. And therefore, the slope of the ramp, which is what they're looking for in the question, is equal to 1 over 10. Okay, let's try example number 2. Example 2 says, calculate the slope of the ramp in the diagram. So it's very similar. We're looking for the same thing, and we will be using the same equation. So again, I'm going to write m equals rise over run. In this question, though, we do have a diagram. So they gave us the 4 meters, which represents our run, our horizontal distance. And they also gave us the 2.5 meters, which represents our rise. A key thing to note is that this time we do have a decimal. We had the 2.5 here. So when we put it back into our equation, instead of simplifying this as a fraction, we could actually plug this into the calculator, and you're going to find that you're going to get 0.625. So all I did was 2.5 divided by 4 there. Therefore, the slope of the ramp is equal to 0.625. Similar to question 1, we can make also another statement that kind of relates rise and run. So here we're going to say the ramp this time rises 0.625 meters for every 1 meter run. And the reason why we put 1 run is because we have a decimal. So, or anytime you have a whole number here and it's not a fraction, it's going to be for every 1 meter run. Okay, so example 3, I actually left you guys for extra practice. And the diagram shows you 3 different ski hills. So ski hill A, B, and C. And using your knowledge on slopes, so you're going to be using the exact same equation. I want you to find the slope and then rank the hills in order of steepness from least to greatness. Moving right along. Before we go over to example 4, we have some new definitions here, some new terms that's important to remember. So when we go over the types of slopes, a line that rises from left to right is known as a blank slope. The key word here is rise. So again, we're rising and we're going from left to right. So think of it as a line segment from here rising to there. Because we're rising, we're going to have a positive slope. Now, a line that falls from left to right, keyword falls, that's going to start at the top and then fall down to the bottom right. This will have a negative slope. And the reason for this is because we're going down, which means our rise value is also going to be negative. Now the slope of a horizontal line, this one might be tricky. This one is actually going to be 0. The reason being is if you remember, slope is equal to rise over run. And in a horizontal line, we have no rise, right? Because we're not changing in the y direction. We're not going up, down. So think of a rise of 0 over anything. So let's just say 5, for example. And 0 divided by anything is going to be 0. So the slope of a horizontal line is and always will be 0. For a vertical line, the slope is going to be undefined. This one might be a little bit tricky. So think again of a vertical line. So we're going to draw one that goes here. Using the same kind of logic, we're going to say m equals rise over run. And this time, let's say the rise is 5. So let's say we went from 0 to 5. So we went up 5 units. Now, what's our run? Did we move left or right or horizontally? No. So because we didn't move left or right, we have a run of 0. And if you were to type that in your calculator, 5 divided by 0, you would get a math error. And the idea is that you can't divide by the number 0. And anytime you do, you're going to get an undefined answer. Okay, example 4. So keeping this in mind, because we will revisit it in example 4, it asks us to calculate the slope of each line segment. Describe the direction and how it relates to slope. So we have 4 line segments, line AB, CD, EF, and GH. And again, we're going to do the same formula. So it might be routine, it might be tedious by now, but essentially what we're doing is finding the rise and finding the slope. Rise, again, is going to be your up, down. Run is your left, right. So if we do segment A, if we're going from point A to point B, think of it as going up 1, 2, and 3 units. So we could write MAB equals rise over run, and we could say that that's equal to 3 so far. When we look at our run, think of it as now we're going 1, 2, 3, 4 units to the right. So we're going to replace run with 4. And that means that our slope AB is going to be 3 over 4. Now, if you remember, since our line segment rises from left to right, and it looks like this, and as you could also tell from the fraction, this will have a positive slope. We'll do one more. We'll do line CD. So doing the same approach, we're going to do our rise. And this time you're going to see that we went down 1, 2, 3, 4, and 5. The key word is down 5. Therefore, when we write our rise over run, we're actually going to write negative 5. Negative because we went down or because we're falling. In terms of our run, we went 1, 2, 3, 4 units. So we're going to write 4 here. And we're going to see that our fraction is going to be negative. Negative 5 over 4. And in this case, we could also confirm that because we have a slope that falls down when it goes from left to right. So this will have a negative slope. Feel free here to pause the video, and I want you guys to try question C and question D. So you're going to be finding the slopes of EF and GH. And if you have any questions, the answers will be posted on the worksheet on Brightspace. Okay, so I promise we are almost done. This is the very, very, very last thing that we're going to do. So by now we know that we could calculate slope using rise over run. Time and time again, I said rise over run, rise over run. Well, we could also calculate slope using a formula. And this formula is useful for when you have two coordinates. So think of the run as a difference or the change in x. Using this same logic, think of the rise as the difference or the change in y. So imagine you're on a skateboard and you start at point 1. And then you slowly go up the ramp to point 2. Well, as you do that, the xy coordinates of your position are changing. For example, our coordinate here is -2, 0. And as you go up the ramp, both the x and the y coordinates continue to change. Your x coordinate is changing because you're traveling to the right, and your y coordinate is changing because you're traveling up. Now, since our line is made up of 2 points, the equation can be written as y2 minus y1 over x2 minus x1. Now you might be thinking, well, what are x1, x2, y1, y2? Why are we working with so many variables? Well, going back to our example, point 1 will be x1, y1, and point 2 will be x2, y2. Now it's important to remember that point 2 will always be the point furthest to the right. So let's put it all together. To do this last example, let's head over to Desmos. So Desmos is a free online graphing tool that makes it easier to graph points, lines, and equations. So what you're going to do is you're going to type Desmos graphing calculator on Google, and I want you to click the first link that pops up, and it should bring you to this page. To graph points on Desmos, we first have to make a table. And to do that, we're going to click this plus sign here on the left, and it's going to give you options, and you're going to click table. This should pop up. Let's just make up some points. So let's say point A is 3, 8. Well, to put that, you simply type 3 in the x column and 8 in the y column. Now, if you don't see the point on your graph or on your computer, you might need to zoom out. So you're actually going to click this minus button. And if you want to position your screen, you could just click and drag your mouse. Okay, perfect. So now again, a line segment is made up of 2 points. So let's make up another one. So let's say our second point is 9, -2. So now that you have those 2 points, to connect those 2 lines, you're going to hover over this icon, and you're just going to hold it. So you're going to click it and hold it until a window like this pops up. And as you can see, we could change the colors. I have a preference for purple, so I'm just going to do that really quickly. And now to connect our 2 points, we simply click the slider where it says lines. And as you can see, you have different options here, so it really doesn't matter. I'm going to pick the solid line here. And finally, to add labels to your points, simply click the point and the coordinates should pop up. And from here, I'm going to manually label this point, so I'm just going to write it on my screen as point A and this one as point B. So out of our 2 points, which one is the furthest to the right? Well, in this case, B is furthest to the right. So right away, I'm going to label that as x2, y2, and point A as x1, y1. Now, if you remember this new formula for m is equal to y2 minus y1 over x2 minus x1. Now we simply plug that back into the equation, and we get -2 minus 8 over 9 minus 3. From here we simplify, and if you don't remember how to add or subtract integers, I always think of it as a point system or a number line. So for -2, that would be, for example, here on a number line. So let me just draw that really quick. And since we're subtracting 8, think of it as going 8 units to the left. And eventually we get -10. On the bottom, we get 9 minus 3, and that's pretty straightforward. And we get 6. So from here we find that the slope of our line is negative 10 over 6. And to simplify this, we can divide both the top and the bottom by 2 and say that our slope is negative 5 over 3. And again, for our last statement, this means that for every 5 units that we go down because it's negative, we go 3 units to the right. And that's the end of our lesson.